the second half of this first video, which is one-step equations, now we are going to add rational numbers. Let's write that on our line up here. Rational numbers are simply, the basic definition is that anything that can be written as a fraction. So yes, your favorite, we are going to be working with fractions and decimals. So let's start with number 7. Remember from the other video, the first thing we ask ourselves is what operation is going on. And we know 6 is being multiplied times x. So we have to say what's the inverse operation, and the inverse operation is division. So let's divide both sides by the number being multiplied by x, which is 6. And 6 divided by 6 is a fancy form of 1. We cancel those out. Now we just write the x because that's all that's left. Don't worry about it. Negative 16 divided by 6, well, it doesn't go in evenly, does it? So we need to simplify. Maybe if we divided both the top and the bottom by 2, we could get a simpler fraction. I think we get negative 8 over 3. Okay. We could leave it just like that, but I would like to change it to a mixed number. I know 3 goes into negative 8, negative 2 times. Okay, so I want you to think for a second. 3 times 2 is 6. Can you hear the change of classes? 6, the difference between 6 and 8 is 2, so I have a remainder of 2 that I use as my numerator now, and that's out of 3. For this one, I'm not going to have you do a check, but you should check on your calculator to make sure that we're correct. Let's go to number 8. What's the operation going on here? We're adding to x, so we have to subtract. That's undoing the problem. Whatever I do to one side, I have to do to the other side. Now remember, when we're working with decimals, you always, when we're adding and subtracting, you always have to line up the decimals. What's left here? Well, 2.5 minus 2.5 becomes 0. I'm left with x. And on this side, I have 7.5 minus 2.5, which leaves me exactly 5. I subtracted, and there were more positives than negatives. So the answer is 5. I could write it like that as a decimal, or just simply 5. Okay, number 9 is the scariest one for you guys because it's going to take me a little bit to explain it. Again, you ask yourself, what's going on here? Well, what's going on? I'm multiplying 2/3 times x, which means I have to do the opposite. The opposite of multiplication is, yes, it's division. So divide both sides by 2/3. And I know you're thinking, oh gosh, I don't want to divide fractions. Well, this isn't really too hard. Now again, on this side, nice and easy. Anything divided by itself becomes 1. I'm left with 1x. Okay, now on the other side, that's where it gets a little bit trickier. So I now have 8 divided by 2/3. And I'm kind of running out of space here. You might have to write to the side. I know when I divide fractions, I have to write my 8 as a fraction over 1. I change this to multiplication, and I flip. So now it's 3/2. Oops, sorry. Phone call. Now I want you to think for a second. Could we have, instead of dividing by 2/3 way up here, could we have just multiplied by its reciprocal to begin with? This is the reciprocal here. It's 3/2. So if I multiply straight across, I know that 8 times 3 is 24. 1 times 2 is 2. 24 divided by 2 is 12. Okay, working down to number 10. X is being divided by 3, so we know we need to multiply both sides by what it's being divided by. Always show parentheses. It's the best way to show multiplication. Otherwise, it gets very confusing. Please do this on your paper. This really means 3 over 1. And if I'm multiplying 3 over 1 times x over 3, I end up with 3x over 3. And 3 divided by 3 is 1. So those cancel out. And 7 times 3 is 21. And always go back. This is a negative. This is a positive. A negative times a positive is always negative. So our answer here is x equals negative 21. Number 11, x is subtracting 1.6. What's the opposite or the inverse of subtraction? It's addition. So I'm going to add 1.6 here. Whatever I do to the left side, I have to do to the right side. Don't forget that. That's how we keep them balanced. Now I get this. X equals, and I want you to remember the signs are different. So I have a negative here and I have a positive here. The signs are different, so we need to subtract. So I need to rename and regroup. I had a 2 here. I can't do 2 minus 6, so I'm going to borrow some 10s. I'm going to borrow 10 from the 80 and make that a 70. I'm going to move those 10 over here, so now I have a 12 here. 12 minus 6 is 6. 7 minus 1 is 6. I have 6.6. So far, so good. Now I'm multiplying negative 4 times x. If I divide both sides by negative 4, that means negative 4 divided by negative 4 is a fancy form of 1. X equals, and look at this, I have negative 2 divided by negative 4. Negative divided by a negative is a positive. And we get 2/4, but that doesn't look like simplest form for me. So I'm thinking we could make 2/4 1/2. Make sure you have all these notes if you don't. We're on to a word problem now. If a chocolate pie is divided into 6 equal slices, and each slice has 280 calories, how many calories are in the whole pie? I know there are 6 slices, and I know each slice is 280 calories. I need to know the whole pie calories. And I'm writing very short words here because it's so hard to write. Plan and work. I am going to draw a tape diagram because to me that helps me decide what I need to do. I know that this is my pie, and my pie has 6 slices in it. I don't know how many calories are in the whole pie, but I know every single slice has 280 calories. So if I'm looking for the whole, I wonder if I could just do the whole divided by 6 slices equals 280. And if I did that, that means I could multiply both sides. I'm going to rewrite it up here in a different form so you can see the normal way we write it. X divided by 6 is 280. And if I multiply each side by 6, because that's the inverse operation, I should cancel those out. And that means, wow, this pie has lots of calories in it. 280 times 6 is, carry the 4, this is 1,680 calories. Make sure you have all of that. I hope that makes sense. We have an online quiz next. Please don't forget to submit your notes.